So today we're going to answer the exercise 1.41. So this is under section 1.9 unit vectors under chapter 1 units physical quantities and vectors. So we're using the University Physics with Modern Physics. This is 13th edition. Okay. So in this problem, so write each vector in figure E1.43 in terms of the unit vectors I and j. Then use vectors to express the vector c, where c is 3 times vector a minus 4 times vector b. So find the magnitude and the direction of vector c. Okay, so let's try to answer this problem. Okay, so here, uh, so So for letter A, so write each vector. So for vector A, so we can write any vector in a unit vector form where it's I hat plus ay, okay, j hat. So that's for vector B. Okay, all you have to know is to find the ax. Okay, in this case, ax is just a cosine of here 70 degrees, where a is equal to 3.60 meters. So it implies that 3.60, so we have here 3.60 meters cosine of 70 degrees. So your AX is 1.23 meters. For your AY here, okay, so for your AY, so you can use a sine of 70 degrees where you have 3.60 meters sine of 70 degrees. So you will have 3.6 sine 70. So you will have 3.38 38 meters. So since you have this already, you can write your vector A in terms of your unit vector as 1.23 meter I hat plus 3.38 meter okay j hat. So that is for vector A. Okay, so for vector B, for vector B, okay, for vector B, so you can find your bx, okay. So your bx is just uh so you need to first to find the angle. So what is the angle of so from positive x-axis to bx, this is your theta b. Okay, that is your theta b, where your theta b is just that is the angle from the positive x-axis to the vector b. Your theta b is just 180 degrees plus 30 degrees, okay, which is 100, 210 degrees. So 180 plus 30 is just 210 degrees. So it implies that your angle is 210 degrees. So your bx, so if your x component, if you use this angle, then 210 degrees, and you can write cosine for x and sine for y component. So just b cosine of 210 degrees. So this is just equal to, so your b is 2.4 meters cosine of 210 degrees. So we have 2.4 cosine of 210. So we have here negative 2.08 meters. Okay. For your by, so you have b sine of 210 degrees implies that your b is just equal to at 2.4 meters sine of 210 degrees. Okay, so 2.4 sine of 210. So you have 1.2 meters. So this is actually negative 1.2 meters. Okay. So it implies that uh your your vector b, you can rewrite your vector b as just negative 2.08 meters I hat plus negative negative 1.2 meters okay j hat. So that is the answer for letter A. Okay. So if you want to answer for letter B, so let's start to answer. Use this for letter B. Use the unit vectors where use the unit vectors to express the vector C, where C is just 3 times vector A and minus 4 times vector D. Okay, let's answer this problem. Okay, let's answer this problem. So your C, vector C is just 3 times vector A minus 4 times vector B. So in that case, so this is your vector C is just equal to 3 times the vector A is just 1.23 meters I had. So let's just write this, let's just write this as this one. Okay. So 1 meter I had plus 3.38 meters J hat. So minus, okay, minus 4 times vector B, where vector B is negative 2.08 meters I had plus, okay, plus, so we're gonna continue here, plus negative 1.2 meters J hat. So that is for, okay. So now we distribute 3. So, okay. So we have 3 times 1.23. So we have 3.69. Okay, we have here 3.69 meter J hat. Now is 3 times 3.38. 3 times 3.38. So we have plus 10.14. So 10.14 meter J hat. So we're gonna multiply negative 4 times negative 2. It will become positive. So plus 4 times 2.08. So 4 times 2.08 is positive 8.32 meter I had. Then negative 4 times negative 1.2. So it will become positive. So plus. So we have here 4 times 1.2. So we have 4.8 meters G. Okay. So then let's combine like terms. Okay, so let's combine the I hat, okay. 3.69 plus 8.32. So it have 12.0. So we have here 12.01 meter I hat plus we combine this one, the J and this one. We add this one. So 10.14 plus 4.8. So we have 14.94 K J hat. So this is our vector C. So that is our vector C. So we have 12.01, 14.94 J hat. So if this is Cx and this is Cy, we can now get the magnitude of this vector C. where this is just the square root of cx squared plus cy squared. So this is equal to the square root of 12.01 squared plus 14.94 squared. So we have so square root square root of 12.01 squared plus 19 point, so is it 19? Let me check again. 14.94. Okay. 14.94 squared. So we have 19 point, the our magnitude is 19.17. Okay. So 19.17. That is our magnitude. So this is equal to 19.17 meters. So we forgot the unit, so meters. So if you want to find the magnitude, so if you grab this one, so if this is your x and y, this is your x and y coordinate. So you have positive cx and positive cy. So you have positive cx, so meaning your positive, this is your x component and this is your y component. So your vector lies on this axis. Okay. You want to find this angle theta here in that direction. So you can use this tangent of theta is just equal to the opposite. The opposite of this angle is cy over cx. So theta is just equal to the tangent inverse of cy over cx. So we have, so this is equal to, so the tangent inverse of cy is 14.94 over 12.01. Okay, so that's the case of 14.94 is the tangent inverse of 14.94 over 12.01 is 51.2 degrees. So we have 51.2 degrees. Okay, so that is our answer for exercise 1.43. So for more videos like this, please subscribe to our channel for more posting of solution manual for this kind of problem. So thank you everyone for watching.